1. Remember to look up at the stars and not down at your feet. 2. Never give up work. Work gives you meaning and purpose, and life is empty without it. 3. If you are lucky enough to find love, remember it is there and don't throw it away.
惑星間パギクヤスト。全人類の利益のための宇宙探査。あなたのホスト、ここイギリス2ノルウェー、マッシュ・ラッセル2、クリス・カーニー。
Stephen Hawking.
I went out on me do-do-do's a little bit too early there, didn't I?
Chris,
Hello.
Carney, how are you?
I'm fine, thank you, Mr. Matthew Russell. It's this week has flown by. I can't believe we're back on talking to each other again. It's great, of course. I'm very happy about it.
What's crazy is it's been a busy week, but it's been a busy week out in space. So many things seem to be happening.
Yes.
There was a huge one with the SpaceX static fire of Starship all going wrong.
Oof.
It almost blew up. But they've got one of these burst disk, part of the pipeline that if it gets too much pressure, it sort of gives way as a kind of safety feature. That avoided an explosion, taking out all the Raptor engines. This was going to be a big one, SN8 prototype.
Yeah.
So that didn't go very well.
But it's a relief. Nobody was hurt, no explosions, so that's good.
And then Musk has got quantum COVID. Sometimes he's got it and sometimes he hasn't. And he's experienced symptoms of a typical cold. I'm not quite sure what Musk is up to when it comes to COVID. He's actually very irritating.
Do you think he might be borderline conspiratorial theorial?
Kind of does want to push that agenda, which is bizarre. Actually, really bad news, is another cable has snapped on the Arecibo dish.
No!
Bad news, because presumably it did more damage, but the cables are the bit that are carrying the the big bit of technology that moves around, picking up the signal, because the dish itself is so big it doesn't move, so this other thing moves around. So presumably the cable is what's holding that up, and if cables are snapping, that presumably means that at some point the cable could snap properly. And according to someone, a director at the observatory, it's got a 50% chance of the whole lot coming crashing down.
I don't like those odds, Matthew.
That is bad odds. That really would be the end of the Arecibo dish, which is iconic to say the least.
Absolutely. James Bond iconic.
Exactly. GoldenEye fight iconic. Wow. Yeah, it'd be absolutely tragic if that goes. So I really, really hope that they scramble to get that thing fixed before it's all too late.
I wish them all a very good luck. And if they need somebody to be lowered upside down in all black, then I am obviously there to do that with my James Bond looks.
Beautiful. Did you see in Nature there was an article about how Europa's Jupiter's moon, which is already exciting enough as it is,
absolutely,
glows in the dark?
Yes, and I don't understand it. Could you explain it to me?
The way I see it is, I think they're saying that it's highly likely that there's chemicals in the ice that will be excited by the ridiculous magnetic fields of Jupiter. So in some ways, a little bit like the Northern Lights in the fact that the Aurora Borealis and all that glowing is caused by magnetic fields and charged particles.
Yes.
Or maybe a similar sort of thing will happen in Europa's ice. So this was Murthy Gudapati at NASA's Jet Propulsion Laboratory in California. Have been looking at whether Europa's icy surface might glow in the dark, which if it does, would actually be really, really handy, because, of course, then you could use that faint glow to try and work out the composition of the possible subsurface ocean. And if you know that, then you might know whether there's life in there.
I think there is.
You think there's life in Europa's oceans?
Yeah, I've just got a feeling. I know there's a lot of science to get through, but I've just got a feeling.
I've often found that feelings trump science.
Oh, yes, they do.
No, that's actually not my experience at all.
Yeah, we need
I
to
think
clarify
that's
this.
not
That I may be joking a little bit, but I think it's more of a hope. It's a hope.
Well, we should. Talking of Trump, by the way, he has
Yeah.
actually conceded. So this is big for what's going to happen in space over the next few months.
Yes.
So
Absolutely.
we'll have to keep an eye out on that. But however, in the European Space Agency, they have announced a mission called Ariel. So that is now good to go. So that is going to be a spacecraft that's going to launch in 2029 and will start doing spectroscopic observation of exoplanets, studying their chemical composition of their atmosphere. So it's using all the other satellite information like Cheops and obviously what's it called? What's the big planet hunting satellite called?
The big planet hunting
Oh my
satellite.
God, Kepler.
I think is that the
Kepler.
The BHS.
The BHS. That's British Home Stores.
Yeah,
I
they've got a
think you're getting
cafe.
confused.
It's got a cafe in there.
So that's an ace one. So we'll have to do a big dive on Ariel because that looks like a very exciting mission. Ukraine also has signed up to the Artemis Accords as well, joining the UK and 7 other countries. So that's 9 in total now, I think, joined up to the Artemis campaign.
That's wonderful.
Chris, I thought I'd point out that I've got a fantastic interview today with Dr. Emma Chapman.
Dr. Emma Chapman.
Royal Society Research Fellow.
Oh.
Really, really nice, super down to earth, mega excited about astronomy. Has written a new book called Switching on Stars at the Dawn of Time, First Light.
What a title. That's lovely.
Yeah, well, it's out on the 26th of November. I've been making my way through, and I love the prose. Very, very, very cool. Drags you in. Man, what an exciting time for astronomy this is. As you'll hear, Emma's brilliant. So that will be at the end of the show.
Excellent.
Now, Chris.
Yeah.
Have you heard of Victor Glover?
Is he related to Donald Glover?
I don't think he is related to Donald Glover. You could ask him the next time you see him, though.
I will.
I mean, I just don't know. But I tell you what Victor Glover deserves is Astronaut of the Week!
Yay!
Well, we haven't had an Astronaut of the Week for a long time, and I thought this guy's so cool that we have to have him as Astronaut of the Week, because in about 6 or 7 hours from when we're talking now, and probably before the podcast comes out, he'll hopefully be flying up to the International Space Station on a Crew Dragon, which will be his first trip to space. Imagine that, being the pilot of the first operational flight of the Crew Dragon. This is basically USA back in business after the shuttle retired.
No pressure, Victor.
He's a kid from the inner city who's made it all the way to be a pilot of a spacecraft. Not just any old spacecraft, but one of the coolest spacecrafts ever. So,
nice.
Do you want to hear a little bit about him?
Please tell me about him. He sounds awesome, so let's do this.
Where do you think he's from?
Good old US of A.
He is from the US of A. He's from California.
The Sunshine State.
Well, how often do you hear this about an astronaut? He graduated from high school as an Athlete of the Year. So 1994. So he was obviously the best athlete in his year. And he went to California Polytechnic State University on a wrestling scholarship. which is crazy, isn't it? Which meant that he got to study general engineering and got his bachelor's degree in general engineering. He's gone on to get 3 other master's degrees. Now, get these. These are brilliant. Flight test engineering, system engineering, and this one is absolutely brilliant. Military operational art and science.
This is incredible. Art and science coming together in a beautiful way, but with
It's
military.
Well, it's the art of war, isn't it?
The art of war. Okay, I'm with you.
And as it
amazing.
says in the art of war, yeah, or something like that. I can't remember exactly what they said. Military operational art and science. He then joined the Navy. Well, I think he's been doing those master's degrees over the course of what I'm going to say next. But he joined the Navy and became an FA-18 pilot in 2001 and was deployed in Iraq on the USS John F. Kennedy as part of a fighter squadron. Then he became a test pilot, 2007. Then he was the head of the strike fighter squadron stationed in Japan in 2011. So over the course of his flying career, he's done 3,000 flight hours in more than 40 aircraft. And he's, when they come into land and the aircraft carrier has that little hook, captures them. He's done that 400 times or over 400 times, and has done 24 actual combat missions. Wow. So I mean, bear in mind, Chris, when were you born? What year were you born?
1979, Matt.
So this guy is 3 years older than you, so you still have time.
Well, do you know,
He's 5 years younger than me, which is depressing.
I checked my health app today, and I've done 0.01 miles.
Ouch! Yeah, I've done a similar disastrous day of just sawing up bits of wood. That's all I've done today. Not quite. Flying a fighter jet and landing it on an aircraft carrier doesn't quite have that same excitement. Yeah. Well, even funnier is his instructors gave him the call sign Ike. Not after the crazy journalist stroke god fantasist. But from it's an acronym for I know everything.
Yeah.
So clearly he was a bit cocky, old Victor. Bit cocky, but probably deservedly so. Then he went on to work for John McCain before being selected for NASA in 2013 as part of Group 21. And then he's finished his training in 2015 and then assigned this space flight, the first commercial Crew Dragon flight. And that's what he's been training to do. And tonight is his opportunity to show all that experience paying off. How cool is that?
Yeah, well, that's the thing. When you first told me that his first flight was going to be piloted by him, I was like, whoa, are you sure? And then you've just told me all that, and it's like, yeah, he's going to be all right.
He's going to be all right. What's funny about spacecraft, of course, is there's something a little bit annoying about them in the fact that I don't think that the pilots have to do much. It's virtually all automated. Well, it is all automated. So it's weird, isn't it? You've got basically one of the best pilots ever sitting back and watching the computer do it all for him. I know, obviously, he might have to do something like dock it if the automatic docking fails or something like that. But it's funny, isn't it, that?
He probably won't really do very much. And it's actually, if he doesn't do very much, then it's a good thing.
Yeah, I should imagine if he has to do stuff, that's like a bad thing. Yeah.
This sounds a bit like lockdown.
If you have to go anywhere, it's a bad thing.
if I have to take off my duck print pajama bottoms,
Yeah, I know what you're saying.
happy.
I still am not a fan of the SpaceX spacesuits. They
No.
only look good on like models, but they just don't look very good on everyone else. They just look a bit someone going for their Sunday motorbike ride. I'm not a fan. Not a fan.
Well, I like them.
Okay. Well, what do you want? A medal? Why don't you just marry Elon Musk? I don't know.
Drink.
Well, we're going to have a drink at your wedding.
Yeah.
After all of this, Victor been doing all that stuff, 3 master's degrees, flying fighter jets, training for NASA. He still had time to have 4 kids with his wife.
Amazing.
What the hell? So annoying. So yes, he should be flying on the Crew Dragon spacecraft Resilience, which is quite a cool name, isn't it?
I've got a better nickname for him. His call handle should be I've, as in, no, I'm gone. I've done everything.
Yeah, well, when he comes down, he'll be called I'd. Yeah, I like it. He's flying up with Michael Hopkins, Shannon Walker, and a really cool one, the JAXA astronaut, Soichi Noguchi. Now, he has flown, this will be his 3rd spacecraft. So he's been up on the shuttle, he's been up on the Soyuz, and now he's going up on a Crew Dragon. I think he's the 4th person ever to do that on 3 different spacecraft. So if he can get himself in another spacecraft, like the CST or something, the Starliner, then he really will, be the king.
Yeah. I was like Starliner. Just the phone keeps ringing in a few months' time, and they're going, "Oh, it's Soichi again." He's just trying to muscle his way onto this flight.
Because it's all about the records, isn't it? It's not about the training and the mission. It's just about what records you can get.
Absolutely, Norris McWhirter is just waiting to hear. That's it. That's what it's all about.
When do you think that this Crew Dragon, that commercial spacecraft, was supposed to be flying? What do you think the original date was for this flight?
I think that it was supposed to go up in 2016.
It was November 2016. Well
Fantastic.
done. Well done. Yeah.
Thank you very much.
4 years late. That's a lot of money spent on Soyuz seats.
Yeah, it certainly is. Yeah, it certainly is. But, you got to do it right.
Yeah, and Resilience will hopefully splash down in about 180 days in June, and will be hopefully used again. How cool is that?
That's the goal.
I've got one story before we go to our interview. Would you like to hear it?
I would love to.
Did you love Magnetars last week?
Oh my God, I've been thinking about Magnetars all week.
Well, get this. This is another Magnetar. So just like buses, it's another Magnetar story. Well, it could be a Magnetar story. It does look good, this one. There was a short gamma ray burst that again flooded over Swift, the NASA orbiting observatory. And it was coming from a star-forming galaxy that is about 6 billion light years away. This all happened about 5 billion years ago, but because of the expansion of the universe, the actual galaxy is now about 6 billion light years away.
Yes.
So Swift instantly skewed to have a look at this thing, and they started pointing lots of the other telescopes around at this very, very bright burst of energy out there in the depths of the universe. And what they saw was something that looked very much like a kilonova event. Now, did we talk about kilonovas last week?
I don't think I know about kilonovas.
What do you think it is? What do you think a kilonova is?
Okay, it's got something to do with stars and maybe something to do with the 1,000? Or is it...
No, it's not a kilonova.
Oh, right.
I hear what you're saying.
Thanks. Go on, fill me in.
Well, it's like a supernova, except ridiculously more powerful. And what's actually happening is it's 2 neutron stars colliding with one another.
Oof.
Yeah, and obviously these very, very dense objects smashing into each other causes havoc. But I tell you what it does do is seed the universe with gold and platinum and uranium and things like that. So that's where these really, really heavy elements come from, is these kilonova events, because obviously the energies and the pressures are so ridiculously extreme. Now, obviously, neutron stars, normally when they collide, the mass of the pair of the neutron stars takes them to such a large mass that they collapse into a black hole and just become a black hole. Now, what's odd about this one is that when they looked at it with Hubble, the signature for a black hole wasn't there. So it's like, so something's happened. We've had a kilonova kind of event. And so all the radio and X-ray luminosities of the afterglow were consistent with an on-axis cosmological short gamma ray burst. But the near-infrared counterpart, revealed by Hubble 2.5 days later, was much lower than on-axis afterglow detections, but is about a factor of 8 to 17 times more luminous than the other kilonova event. There's only been one other kilonova event confirmed, and that's GW170817.
Catchy.
And it's significantly brighter than all the other kilonova candidates that they know of at the moment.
Did the other kilonova event become a black hole?
And that did become a black hole, I believe. One of the explanations, and they give several explanations, but the most intriguing one, and the one that the press picked up on, was this idea that, yes, they collided into each other, but created a magnetar. And that's why this signature is slightly different, and the near infrared is much brighter because the energy, what the magnetar is doing to the light as it leaves. But they've got an experiment to sort of work out whether they're right as well.
They've always got something. They're brilliant.
Yeah. Well, when you read the paper, it's just like mind blowing. But so if it did create a magnetar, what will happen is that we'll receive this radio emission in about half a year to 6 years' time. And so if we see this signature over the next few years, then we'll know, yes, it was indeed a magnetar that was created. And that's really exciting, isn't it?
Very, very exciting. And you know what? If we need more of something, it's magnetars.
Yeah. I mean, the energy released was 10 to the power 53 ergs. So if you were anywhere near that, you would have been
having a bad day.
Completely destroyed. Oh, man.
The power.
So,
Love it.
Chris.
Yep.
You've been on the podcast, what, 5 times now?
5, yes.
I think it's 5, times. which means you get to tell me 5 space songs.
I am so excited about this, and you know, when you told me to look for them, I spent a very long time looking for them. Now there is a chance that that a couple of them might be on the playlist already, but I'm pretty sure there's a couple of them that aren't. There's no particular order actually, so I love all these songs equally. Actually, do you know what? I think one might be my favorite, and I'll see if you can guess which one it is. Okay, so the first one is Kelly Watch the Stars by Air.
Great tune. And
fantastic.
And I believe the artwork for that was the Space Shuttle, wasn't it? The original album had Space Shuttle sort of stuff all over it.
And just an amazing band, and I saw them live a few years ago, and it was just a wealth of beautiful vintage synthesizers on the stage, and I was expecting them to sort of be quite moody, you know what I mean? But they were all like, "Yeah, come on, Oslo," and they were sort of like really upbeat sort of guys. So it was a really big surprise. So I'm a big fan of it, and a big fan of Kelly Watch the Stars. Okay, so at number 4. Yes. Mm-hmm. In at number 4, it's maybe less known, and it's a song called Moon Woman 2, and it's by Elvis Perkins.
Ooh.
Moon Woman 2 by Elvis Perkins is off his debut album Ash Wednesday from 2007. And actually, one of the main reasons I've included it is because I really want people to listen to that album as well, because I really love it. And I was just like, oh, please tell me there's a song in there with a bit of a sort of spacey theme to it. And look at that, Moon Woman 2 is right there. And then for number 3, I thought I'd go for a little bit of balance, and I've gone for Whitey on the Moon by Gil Scott-Heron.
Ooh.
Yeah.
Yeah, it's. Do you know what? I think that might be on the playlist. I mean, I actually love that. I love the track.
Yeah.
But I do genuinely disagree with the sentiment. I always think that it's not one or the other. That we should celebrate, trying to achieve things. But I definitely appreciate the time that it was written at and everything that was going on. I mean, yeah,
completely.
It's
a disenfranchised.
It is a classic.
It's the voice of the disenfranchised at that time, and obviously racial segregation. And yeah, I'm glad it was said. Because it's a fantastic poem, and it's by one of my favorite all time. And I also really liked that it was included in First Man. I thought that was a good inclusion of that, because otherwise what you've got there is quite a sort of aggrandized sort of representation of what happened, and just the inclusion of that song just gave you that little bit of balance. And so next up, a classic which I'm pretty sure is on the playlist. It's Spacewalk by Lemon Jelly.
I love that album, but when I saw Lemon Jelly live, that unfortunately was one of the most boring gigs I've ever been to.
Oh no, I've never seen them, so I couldn't comment.
Yeah, but this is a long time ago. It may have just been an off day. I always hate judging people on one performance, but yeah, it was not great.
Oh, that's
great
a shame,
album,
but
though. Great song. Great song.
It's a beautiful album, and the song I never ever tire of listening to it. I think it's just got it's the most joyful song, and his his reactions and the way they've sort of mix that with the music and the peaks and troughs of the actual song. It's just absolutely perfect, and the guitar riff is just something I'd love to hear over and over again. So yeah, never tire of that one. And then the last one it's got a pretty similar feel to it in that sense, but it's a little bit more foreboding, and it must be on the playlist, this one, and it's The Other Side by Public Service Broadcasting.
Yeah, well, the public service broadcasting is. It almost you have to stick the whole album on, don't you? Or a couple of albums,
really. I mean, that's what I was thinking. Probably the entire album is on there. But what I love so much about The Other Side is, again, like what Lemon Jelly did, but in sort of different ways. That's sort of the tension that they managed to sort of communicate to the listener of that moment of going behind the moon. They just nail on the head. It's absolutely wonderful. And I know the whole album really manages to do that, I think, from the Apollo 1 track, right through to the sort of superhero theme tune of Yuri Gagarin. They just every single and that's the same across all of their albums, if I'm honest. I mean, Every Valley, listening to that, I was actually in tears the first time I listened to that, which is obviously about the collapse of the Welsh mining industry. But yeah, The Other Side is just something I just absolutely adore. I get the shivers every time I listen to it. Every time they're waiting for that signal to come back from Lovell, and you just go, is he going to say? Is he going to? Like, is it? He's going to. It happens, but. Well, absolutely, just incredible music. And they're my 5. Can you guess which one's my favourite?
Well, I know which one's my favourite. I think the Air track's my favourite. But actually, I think, or Whitey on the Moon as well, because it is so. It represents a point of view that's that we don't often talk about. I don't know which one's your favourite. I'm going to go with Air. Is Air your favourite?
It's The Other Side by Public Service Broadcasting.
Oh.
That's the end.
I thought you were not going to say that one because you'd bigged it up so much when you were talking about it. You were trying to trick me.
You're trying to throw you off the scent. Well, I'm sorry, Matthew, but you don't appear to have won this week.
No, well, that is 5 solid song choices right there. Absolutely.
Thank you very much. Join us tomorrow on Popmaster. Thank you.
I'm tell you what though, Emma Chapman. Also, I sprung the music question upon her.
Yeah,
but she gave a fantastic answer.
Oof,
like a really, and I really can't wait to check it out as well. I really can't. So, you have to stay tuned to hear what she picks. But it's excellent. It really is.
Awesome.
And it's definitely not on the playlist. Would you like? In fact, shall we just go straight to Emma?
Let's go for it.
Akutai.
The Interplanetary podcast, putting the ace back into space.
I'm joined on the podcast by Dr. Emma Chapman, who's a Royal Society Research Fellow. Welcome to the podcast, Emma.
Thank you. I'm really glad to be here.
You've got a new book out. I love the start about why the night sky is black. So I think that's a good starting point.
This is one of my favourite little tidbits of astronomy, which is that, 100, 200 years ago, they didn't really have the technology to explore the universe very well. And so astronomy was very much a thinking sport. And a couple of 100 years ago, lots of people looked up and they wondered, why is the sky black? Because if you have a infinite universe in space, in time, which is what they considered it to be at that time, then every line of sight you look down should eventually land on a star. And if you calculate this, if you figure out how much radiation is coming from these stars now, obviously then they just worked theoretically in that way, then the sky should be as bright as the sun all over. So to break a paradox, this is called Albus's paradox, after one of the people that formulated it. But everyone chipped in at the time, even Edgar Allan Poe in an essay. So to break a paradox, you have to break the assumptions. And the assumptions that this paradox made were that the universe was static, so unmoving, and that it was infinite in time. And of course, both of those are wrong. Now we have the Big Bang Theory, which postulates that both the universe is finite in time. So there was a beginning, and this is vital for my research. There was a beginning. There is a first of everything, including a first star. But also the other assumption is wrong, which is that the universe is not static. It's moving. It's expanding. And so, Big Bang Theory really breaks this paradox. But it's just a wonderful introduction into how astronomy started.
Yeah, I think it's a brilliant introduction to science as well, in terms of how thinking about the more than obvious. It's like thinking about, well, why is the night sky black? And it ends up being a ridiculously hard question to answer. So at what point did astronomers crack it? When can an astronomer put their hand up and say, we've now cracked why the night sky is black? Or dark?
That's a tricky question, actually. So I would say that it was when Big Bang Theory was postulated. So that's like the late 1920s, 1930s. But it took a long time for scientists to really believe the Big Bang Theory, because it was just against everything they believed. And even the best scientists, when they are presented with evidence and facts against something that they have really, really held on to as true for a very long time, even the best scientists can ignore that. Einstein's a famous example of that. When he did his general relativity equations, it fell out that the universe was expanding, and this was so abhorrent that he actually put a fudge factor in. Even Einstein can be wrong, and I try and tell myself that every day when I don't understand something. So it really did take a while for people to really get on board with the Big Bang Theory, and it took two major pieces of evidence, really, which was that all of the galaxies around us are speeding away from us, with a couple of exceptions, but the vast majority are. And I always say that, this is like an explosion in an action movie. Bruce Willis goes one way, you've got Sylvester Stallone going the other way. They all just, off they go on their trajectories, and it's the same with the galaxies. So that's a hint at an explosion. And the other one is that we've actually managed to measure the background radiation. So, you see people in this action movie shield their eyes. The explosion's so bright, all this radiation. That's exactly the same with the Big Bang. This is the biggest explosion you can possibly imagine. Huge amounts of really hot radiation all over the universe. That's cooled down with time, with the expansion of the universe. It's in the radio microwave wavelengths. We've detected that, and it's exactly what Big Bang Theory predicts. So now, very, very rare to find a scientist that isn't on board with Big Bang Theory.
So I guess the Big Bang Theory then means that we have the title of the book, really, the first stars. If there wasn't stars before, there has to be first stars. So presumably that's what the book is about.
Absolutely. The book is about the cosmic dawn. So about 400,000 years after the Big Bang, you get this radiation really starting to cool down. And if there was an observer there, let's say Doctor Who has taken his TARDIS over there, what you would find is that it's very dark, it's very boring, nothing seems to be happening. But kind of behind the scenes, what's happening is that lots of hydrogen gas is coalescing together. And eventually, enough of that hydrogen gas comes together that it sparks fusion. So two hydrogen atoms being forced together, that releases energy. And this first star lights up. And then another one, and then another one. So it's like twinkle lights in the sky all over the universe. And suddenly we start to see. And those first stars, they really changed the universe. The universe after the Big Bang was very boring. It was filled with hydrogen, helium, pretty much it. After the first stars, what they're doing is they are factories for the heavier elements, which we call metals as astronomers. So they start fusing, lithium, beryllium, boron, all of these heavier elements. And when they die in incredibly strong supernovae, very, very bright, very, very violent, they seed the universe with these metals. And it's only with these metals that you can cool down gas enough to form galaxies, which then you get planets, and then you get me. I'm made of heavier elements. We are made of star stuff, as Carl Sagan once famously said. The thing about these first stars is that we've never really got any observations of that time. It's about a period of 1 billion years that we're missing in our evolution of the universe that we want to understand. And that's this whole era of the first stars. So their formation, their lives, how they changed the universe.
Would that be sort of an analogy to how life got started on Earth, how sort of cosmic life got started, that we're missing that biogenesis moment? Is that a fair analogy to the kind of first stars?
I think it's definitely one you could draw. What we say is we have 3 populations of stars. We really like to categorise things as humans, and so we categorise our stars as well. And we determine these by the metallicity content. So population 1 stars like our sun actually have quite a high metal content. Then you've got the older stars, which are population 2. And then what people did is again, they wondered. They asked a question. If we've got young high metal stars, we've got old lower metallicity stars, what about the first ones? What about the ones that were metal free? And so we said there must be a population 3, but we've never observed them. And there's several reasons for that, which my book goes into. I'll only go into them briefly now. We think they were very hot, very massive, lived very short lives, but we think there might have been a tail end of population 3 stars that were actually very small, and they could live very long lifetimes. And the really exciting thing is that they could still be around today in our Milky Way. So there's this fabulous field called stellar archaeology, and they are literally digging up stars digging up fossils, you could say, to fill in this biogenesis. And they're digging up the fossils of the first stars to really try and understand how our universe started. And I do draw the comparison with a human lifetime. What we're missing in our universe's timeline is equivalent to missing everything in your child's childhood, from the point of conception to the first day of school. And if you think about how formative those years are, how much they change, that's why we're quite keen as astrophysicists to fill in all of that data.
What were the conditions? Why were these first stars massive to start with? What makes it different at the beginning of that what's it called? The reionization period. It
took me about 3 years into my PhD before I could actually pronounce reionization. So the epoch of reionization, I should just tell you, is a period from around 400 million years to 1 billion years after the Big Bang. And it's when these first stars got so energetic that they pushed out loads and loads of photons. The galaxies pushed out loads and loads of photons, which ionized all of the hydrogen in our universe. That's important because we can use that hydrogen as a tracer. We can observe how that hydrogen is heated and infer what the first stars were like, where they were. It was different early on in the universe because of what was in the early universe. So without getting too much into chemistry, in the very early universe, you just had hydrogen, you just had helium. And the only way you could cool down was with atomic transitions in that hydrogen. And what happened was that you couldn't cool down your clouds of hydrogen enough that they could keep getting lots and lots of mass, lots and lots of densities, smaller and smaller and smaller. So they kind of had to stay much, much larger. And so you get much larger stars, about 100 times the mass of our sun, about 100 times the mass of our sun. That's huge. There's even simulations which suggest we could get stars 1,000 times the mass of our sun. More recent research has shown that actually around that massive central first star, we could have sibling stars created of lower mass, and they're the ones we're trying to find with stellar archaeology. Very, very quickly, though, 100 million years after they formed, which is a blink of the eye in terms of stellar lifetimes. Our sun's going to live 9 billion years in total. So 100 million years, they explode. They seed the universe with metals, and as soon as you have metals, you activate atomic transitions within those metals, which can cool down the gas so much more that much smaller stars form. So these first stars, they're not like our sun. They are an extinct species. You cannot form them in the universe as it lies today. So they really are the dinosaurs of astronomy.
No sort of pocket of the universe that exists today, it has the right conditions to come close to creating this very, very narrow window of these early stars.
It's very unlikely. So there is the idea that you could have islands in the sky which have managed to avoid all of this reionization, pockets of pure gas. Those are more likely to be more like, oh gosh, that's a really good question. Let's say 1 billion years after the Big Bang, these pockets might still exist. Nowadays, hugely unlikely, because there's just been so many supernovae, so much metallic mixing, so many galaxy collisions. Our universe is a violent place. So it's unlikely to have these fortresses.
So are we in a position now, because I do think of this as a sort of mega golden age of astronomy where we have all these new instruments coming online and gravitational waves. So are we in a position now that we can start hunting for this early epoch and actually delving into the childhood story of the universe?
Absolutely. This decade even is just the best time to be able to be in this field. I'm incredibly lucky. There's several ways we're trying to look at them. So in terms of looking at them directly, I've already explained a bit about stellar archaeology. So that's looking at these little ones. In terms of how they lived 13 billion years ago, how they formed, what we're doing is we're using the hydrogen gas to trace what's happening. And the way we do that is that this hydrogen gas surrounding the first stars is heated and then ionized, and bubbles form around the stars and the galaxies that are doing this. It ionizes the gas in a nice bubble, which gets bigger and bigger and bigger as time goes on. So this is Swiss cheese. If you just imagine a slice of Swiss cheese, you've got holes in it everywhere. That's what our hydrogen looks like. And we are currently looking for that right now. I've been measuring this hydrogen gas. It emits a photon of exactly 21 centimetres, which is very handy, because by the time it gets to us, it's lost so much energy that it's in radio wavelengths. So I use radio telescopes in the Netherlands, and I'm helping to build one in the Western Australian desert called the Square Kilometre Array. And what these telescopes do is they measure the temperature of this hydrogen and they figure out what this Swiss cheese looks like. We haven't quite made the detection yet because it's really hard, because there's so much radiation that gets piled on from every other galaxy in the universe. Our galaxy is very, very noisy. So it's like trying to listen to a conversation on a phone while walking past a pneumatic drill. We have to strip out all of that noise. Luckily, there's methods. So the methods I personally work on in my day job are signal separation. So we use this in music. We use this in MRIs, the dark matter, which gravitationally pulls in the hydrogen to fuse. So yes, it's important, but we'd coded it. We'd put it in our simulations, and so we kind of just walked away from it and been like, it's all cool. Edges came in, and the edges result, if you remember, they measured the temperature of the hydrogen. What they actually measured was that the temperature of the hydrogen was twice as cold as we expected. So it went down a lot further than we expected. And every single model we had of how the temperature should change in the hydrogen didn't fit. Still doesn't fit, actually. This is a contested result. So my colleagues would warn me off from talking about the dark matter implications of this. So my caveat is it still needs to be confirmed. Yeah. But at the time, the theory paper that accompanied the experimental paper said, look, none of our models fit what we've just discovered. The only thing that can make hydrogen colder in the early universe is if it's interacting with dark matter. Now, dark matter is famously unsocial. We even call it the weakly interactive massive particle, or WIMP. If it's interacting with the hydrogen, that is paradigm shifting for the dark matter field, and it's another way of indirectly detecting the properties of dark matter. That's huge. If that's confirmed, yes, dark matter is incredibly important in terms of the later evolution of the universe. If you ask me whether that's actually what's happening, I am more of the opinion that there's a systematic in the data. I think they've detected something. I don't think it's as cold as what they've detected, but we will know in a few years.
So, I mean, that brings a sort of even more interesting point about where astronomy is at the moment, is that you've got all these unanswered questions that are getting closer and closer to being answered. Is there going to be this waterfall moment where you suddenly have, someone saying, but now I know what dark matter is, and then that gets slotted into your models of early stars, and then someone else slots it into somewhere else, and it all starts falling into place? Are we likely to see something like that in the next decade?
I think we're there. I'd actually argue that in the last decade, in the last 20 years, we've got to that waterfall moment, because we've got to the point where we have major collaborations, which means we can fund major telescopes and experiments and observatories. And we're there. We've got so many. We've got multiple space missions. We're even looking, there's so many missions that I can't count them, that are looking at going to the moon and placing radio antennas on the moon to look back to the cosmic dawn. We've got Planck, which was a telescope which measured this cosmic microwave background, leftover radiation from the Big Bang, to incredible precision. We've got these radio telescopes now. We're mapping the stars. We're mapping the galaxies. We're looking at dwarf galaxies. We're there.
So we're collecting lots and lots of data. what's now the sort of priority? Is it the theoretical, or is it the data collectors?
It's the data, because we're at the point where we need incredible signal to noise, as I've mentioned. We need huge amounts of data, and we need complementary data in order to rule out any systematics. That's why we need very, very sensitive telescopes like the James Webb Space Telescope. That's cost $9 billion to create so far. Yeah, and the rest. But apparently it's capped. It's capped at $9 billion. That is reportedly the amount of money that Americans spend on potato chips every year.
Or Halloween costumes, I think, is the other one.
Yeah. So, you have it sounds like a lot of money. It is a lot of money. People would ask the question, should we be spending that money when we're experiencing global warming and global pandemics? It's a drop in the ocean compared to what they actually have in terms of money and I think it's incredible filling in this history. If you look at how fascinated we are as humans with history, where we come from, like 23andMe, these genetic testing kits supposedly, and the looking at the dinosaurs and everything like that. But more than that, the spin-offs from these telescopes now, the square kilometre array that I'm helping to develop, it is at the forefront of technological advance, and that's why governments everywhere are falling over themselves to contribute money to it, because the fibre optic cables that we have at the minute are not able to transfer the data quick enough. So we're driving innovation there. We have to cool down these hard drives that are taking petabytes of data from the sky. That's driving cooling chips. It might look like we're just twiddling our thumbs and looking at the stars, but we're absolutely not. We're driving innovation on the ground as well.
Is there a project that you can see in the future that you think either shouldn't get the funding or another project that really deserves the funding more? I mean, I'm thinking about things like another big, large hadron collider versus a huge radio telescope on the far side of the moon or something like that. What is there anything?
Oh, I can't answer that question without really
winding your colleagues,
peeing off some people because I have multiple people, so I won't answer what I think shouldn't get funded. I think radio astronomy should always get funded because it is cheap for what you get. The SKA, the Square Kilometre Array, is capped at around 650 million euros. That's incredibly cheap for the fact that we are not only looking at the sky, but we're driving incredible computing innovation. I like to call this down-to-earth astronomy. Yes, we're not flying lovely spaceships up. We're on our knees and hands putting antennas on the ground and trying to stop kangaroos kicking them over. It's very down to earth, but it's cheap. But oh my goodness, the stuff you get back from it, both scientifically and industrial, I guess.
Your career sounds like it's so fun. You obviously get these moments of pure inspiration and pure like joy at results, and you get to travel to Australia and stop kangaroos kicking antennas over. So what would you say to people trying to get into this field and what they can do to kind of follow in your footsteps, as it were, and others like you?
I mean, you need to do physics, I guess. So I'm an astrophysicist. You don't have to be the kind of person that stands out at the night with an amateur telescope and learns all the constellations off by heart. That's not who I am. I've owned one telescope. I didn't use it very much, and I can point to a few constellations. I mean, that would make some people sick and think that I'm a fraud. But there's so many different types of astrophysics. That's near field astrophysics. I'm looking at the far field. Doing physics, I didn't know I was going to be an astrophysicist. I thought I was going to be an Egyptologist. Then my head got turned by special relativity and the fact that when you're going very fast, time slows down and you appear shorter. And I just thought it was so science fiction that I went to university to understand it. And it was only in my fourth year that I took a cosmology course, and again, just my mind was blown. I didn't understand it, and so I did a PhD in it to try and understand it, and now I'm a research fellow, and there's questions every day that I don't understand. So I think the key thing you can do, apart from the obvious, you need a training in physics. You've got to be the kind of person that doesn't give up when you don't know the answer. Because that's what every day is. It's not knowing the answer. And yes, there's this thrill when you get the answer and you discover something new, but it's about 10 minutes before you have the next question.
Yeah.
So you need to be a bit tenacious. And
right, I've got 2 frivolous questions to finish this interview up, because I've just realised I've taken almost an hour of your time.
Oh, it's been really fun. Like I said, my morning was spent doing statistics. It's amazing to spend the afternoon talking about why I was doing statistics.
That's great. Well, now I'm going to ask 2 questions that are completely nothing to do with any of it. This is 2 questions I always ask guests that are not really to do with space. Well, they may be. The first one might be, but the first one is: do you have a hero, a kind of person that you would like to bring back from the dead and say, look at what we've achieved? Look at the field of astronomy, or look at astrophysics, and look what we've done.
Cecilia Payne Kiboshkin. She was an earlier 20th century astronomer. She fought incredibly hard to be an astronomer. She was British by birth. She was born about 5 miles away from me. And she fought to study physics in Cambridge when there were greats such as Rutherford and Bohr discussing what atoms look like. So we're talking around the 1920s. She fought very hard. This is a time when people didn't like women to be in the laboratories because they were worried that the corsets would interfere with the electromagnetic experiments. She had to leave England because no one would give her a job, and so she went to Harvard. And she was wonderful. She was the person that showed for the first time that stars were made predominantly of hydrogen. People at that time thought that stars were just really warm Earths and that they were made of the same composition of Earth. And if you just heated Earth enough, it would look like a star. So I've used it for paradigm shifting. She didn't get much credit for it. So she was just kick-ass, to be honest. Like, you read her biography and she just didn't take any rubbish from anyone. And she said to other women, if you want to study science, do it. Study science, but don't do it searching any reward, because you will receive none. Do it because you want to climb a mountain and see the widening horizon. That was a paraphrased quote from hers. And that's what I've sought to do as well. It's the widening of the horizon. And I think she would be proud to be so vindicated, because people didn't believe it. Like I've said, people hang on to their theories. People didn't believe it. They said she'd made a mistake.
Wasn't it Eddington or someone like that was told her that she'd made a mistake?
It was actually her supervisor, Henry Russell. Pretty much everybody told her she was wrong, so it's quite possible that Eddington did as well. She changed her thesis. This was her PhD thesis, by the way. She did this in her PhD thesis. She changed her thesis to say it's probably wrong, because so many people said she'd made a mistake. And it was actually only a couple of years later that her supervisor did corroborate her results and published a paper on it without really mentioning her.
Oh, whoops. The final question is, do you have a song that you associate with space that can go on our space song playlist that we have?
I'm going to go with Beethoven's Moonlight Sonata. Very obvious choice, but possibly not obvious reasons. And it's because there was an artist in residence at one of the universities I worked in. And what she did was she's called Katie Patterson. And what she did was she produced an installation where she took the Moonlight Sonata, converted it into Morse code, sent it to the moon and back. The piece is called Earth, Moon, Earth. And then she played it on a ghostly automatic grand piano. And it's beautiful. And it's disturbing, because in that 3-second-ish journey, it got corrupted, which is what my day job is, right? Signals getting corrupted. And the amount it got corrupted, you can hear it, you can hear do, 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 do. You can hear it, but the odd note gets dropped, the odd note gets lengthened. And it's so haunting, and it's such a haunting reminder of how much we don't understand and how much the universe messes with us. So that's my song.
That's a very, very great choice, and I'm definitely going to be looking it up because that just about floats my boat in about every single way possible. so yeah, that's absolutely brilliant. See, my son would be obsessed with this whole idea of the one type of noise reduction that he's really into is AI noise reduction. And so he would, the instant the first question I know he'd ask me is, if you got an AI, could you get it back to the original Moonlight Sonata?
That's what we're doing. So I've got a PhD student not working on the Moonlight Sonata. That's a fascinating question. Maybe I should do that as a summer project. Thank you. But I have a student which is working on the first star signal with machine learning. One of my PhD students. So AI is everywhere, and it is definitely in astronomy.
Yeah, that machine learning thing has got to be part of that waterfall, hasn't it, of information coming in. Well, that seems like a perfect ending to the podcast. Thank you very much for talking astronomy with me and blowing my mind as it always does.
Thank you very much.
The Interplanetary podcast is alive!
There we go, Chris.
Superb.
Chris, if people liked the Interplanetary podcast, where could they go to find out more?
If I really like this podcast, or even if I just thought it was good, I'd still go to interplanetary.org.uk. And
you could go to www.patreon.com/interplanetary if you want to become deeper part of the journey, or just see some of the other content that we sometimes put there, some nice little snippets of things.
That's something I'd like to see.
What are you doing this week in lockdown?
In lockdown, I've got a little bit of work to do, but not a lot is going on in terms of leaving the house. But luckily, I can take little walks, and I've also found a new mountain bike trail that I can get onto before it gets too cold to ride your bike out here in Oslo.
Oh, yeah, I bet. Yeah, I bet. It's going to start getting proper cold, isn't it? I'm just going to be working this week. I've got so much to do. And I've got to finish off my little DIY project of making a stud wall for the toilet.
Well, you know what, Matthew? I just hope that you take a little bit of time out for you.
Oh, that's beautiful, Chris. Well, thank you, Chris, for helping me out again. And,
a pleasure as always.
Shall we let the Spodcats go and get on with their lives?
Spodcats, we love
bye,
you.
Bye, Spodcats. I can't wait for next week for more space fun and games. Bye.